Thank you very much. So I hope you understand everything. So I'm from Germany. I'm a German engineer, and my English is not perfect. I hope my furnaces are better than my English. Okay. So in Europe, the energy is very expensive, and this is the reason we built our furnace for the maximum saving position. What we want to talk about, when we build a furnace in Europe, we have this furnace on our test field and show how much energy they need and what are the consumers of the different furnace we build. So we have retort furnaces, and we speak about chamber. You call it a vacuum net riding furnace, I think, and pit furnaces. And we will find out where the biggest energy issues are. So why we should do this? In Germany, the German Heat Treat Association told we have something around 15 and 30% of the turnaround of the money is for energy. So this is the reason we have to look out for the energy prices. This is a net riding chamber furnace on our test field, and there we do a hot test of each furnace to find out where the biggest energy needers are, and check the temperature profile, and everything else is okay. After this hot test, it goes away to our customers. These are the furnace we talk about. At first, the net riding chamber furnace and the pit furnace. So, which consumers we have on these furnaces? So we have the torch burner to neutral the gas circulation on the top of the furnace, the cooling air fan to cool it down, the NH3 splitter, the heating, the switchgear, and the gas control stations, sensors, gas blast chillers, and the vacuum pump. So, and now we will see how much energy these parts need for the furnace. So we start with heating up the furnaces. So in orange we have the pit furnace, and in blue we have the chamber furnace. So keep in mind, the pit furnace is 5 times bigger inside as a chamber furnace. So you see, we need for heating up only 3 times more energy for the 5 times volume. We have the flame burner. It starts at the middle of the temperature when we give NH3 to it. Surprise, the heating is the most energy we need from heating up, but also a gas circulator engine needs energy. And don't forget the cooling water. So the cooling water is also expensive and needs energy. More interesting, the temperature is the net riding temperature, the normal, 907 degrees of Fahrenheit. This is the process point of hold. So the most time your furnace is on hold when you have a net riding process, and so you see the flame burner needs 2 kilowatts per hour. This is less, so there are other ring burners need 15 to 20 kilowatts per hour, and when you see you need only 13 kilowatts per hour for the big pit furnace to hold the temperature of 520 degrees, and for the small chamber furnace we have only 5 kilowatts per hour we need. The gas circulation engine, 2.5 to 3 kilowatts per hour, and you see the cooling water is a lot of energy. So the first surprise is when you see the heating needs 5 kilowatts per hour, the cooling water takes away 7.2 kilowatts per hour. So the difference comes from here. The circulation engine produce heat inside the furnace, and there you get the difference back. What you also see, the switchgear and gas control station, it's nothing. Yeah, 400 watts per hour, it's nothing. So it isn't something you have to care about it. So I think you have to show the cooling water and the flame burner. The heating, you need a better isolation, but we will see it later. The next step is cooling down the furnaces, and you see we give a lot of the energy back to the cooling water, so we have a fast cooling with water. The gas is cooling down with water, and there you have a really big engine you can use. Yeah, the gas circulation is always on. The flame burner is a half of time on. So long you have flammable gas inside. The cooling down needs also engine energy for the blast chiller fan, and this is the cooling air fan to cool down the furnace. This is what I talk about when you see how small the chamber furnace is against the pit furnace. And now we have all the data of cubic meters inside loading room from the furnace. Yeah, and then you see how much bigger your furnace is. You doesn't need so much energy to have the same heat treatment. So the heating is less, the cooling water is less. Yeah, switchgear doesn't interesting, and the difference also comes from chamber furnace have two parts on the front and on the rear side to cool down. Yeah, the pit furnace have only on the top a ceiling we have to cool down. So this is we have two chamber furnace against. The left one is gas heated and the right one is electrical heated. The left one is the double size of the right one, the gas heated. And what we have when we have a gas heated furnace, we need an air blower. Yeah, so the electrical heated don't have it. We have also the flame burner and the heating. So the bigger furnace needs a little bit more energy, but it's more energy of kilowatts per cubic meters, but it comes from the gas heated furnaces needs a little bit more energy as the electrical heated. So in my opinion, maybe the gas specialist can say anything else. So we have 30% more power we need for the gas heated furnace. The cooling water is less because it's bigger, and we have only the flanges we have to cool down in the front and on the rear side. But so you see how much bigger the furnace is, and you didn't need so much energy. And it's very important you have a good isolation on your furnace to don't need so much energy on the net riding temperatures, because you stay a long time on this temperature between 5 and whatever 90 hours. So this are furnaces people want to save energy. What they do here, it was a furnace from other furnace builder, they put isolation on the outside of the furnace. So it looks ugly, but you have 10% less energy you need for the temperature of the furnace. So you see the surface temperatures goes down. Yeah, you can do it. It's 10% is not bad to save energy. Yeah, it's not nice, but it works. Second thing is when you have a gas heated furnace, you can change the burners. Yeah, change from a cold air burner to a recuperator burner. So you can save on net riding temperature something around 13% of energy. But the cost, you have to invest 50% more, maybe. Yeah, something like this. Yeah, this is possible. This is easy. When your burners are old, yeah, take them out, give new ones inside, and the effect is much bigger when you have higher temperatures. So we spoke here about net riding temperatures, and when you use them for gas carburizing or something else, the effect is much bigger. So do it. One thing you can do, it's really easy. You can you have your cooling water, and often you give it into your furnace with 18 degrees, 16 degrees, it doesn't matter, and come out. It's not much higher in the temperature, and this is the delta temperature we have, and you see how much water we need. 230 gallons per hour for the pit furnace and 250 gallons per hour for the chamber furnace we see before. When you say, okay, I put the temperature higher, so you can save a lot of water. Yeah. So this is a saving you can have, 180 gallons per hour and 206 gallons per hour you can save cooling water. So cooling water also costs money. So before we tested, I think we have a much bigger effect for the reduction of energy, but this is nearly nothing, 500 watts per hour. So for a furnace, it's too less. Yeah, but when your cooling station is on the limit, so that's the temperature high, and you can save the cooling water. The furnace is good with it. You have to keep out the water quality is good enough that the cooling channels don't be closed. We spoke about the gas circulation. This is the point. So yesterday I learned in the US often they look different. So you have the shaft without the motor. We have the shaft go inside the motor and have here a water cooling bearing, and here is a bearing. So it's in the outside from the furnace. So in this way we have the isolation on the cover. And what I want to say, so this are the different classes of electrical motor we have, and the oldest one and the newest one, they are 10% saving position you can have, but for me it doesn't matter. So your engine have something between 5 and 10 kilowatts per hour you need, so you can save 1 kilowatt per hour, but to change this motor cost you 6,000 euros, I think. It's the same in dollars. So for what? When the motor is defect, you get so or so a newer one. So don't give it away and give you will lose money and have not a big energy effect. And also the fan heat up your furnace. So this energy you put into your process is not loose. Yeah, I think this is the biggest, really biggest point you can watch out on your furnaces. So when you see for a nitriding process, you have a ring type burner on the top to get NH3 gas away. Yeah, and so these burners have something around 15 kilowatts per hour you need. Always when the flame is on, you need 50 kilowatts per hour. So what we see before, a good furnace needs on hold 30 kilowatts per hour. So you burn for nothing so much energy on the top of the furnace to get the gas away. So what we see on this picture, so I found it in the internet, and there we have a pit furnace cover, with 2 ring burner types on it. So on this furnace we burn over 30 kilowatts per hour energy on the top to get the gas away, and this is something you can change it. So when we see this design, so here we have a cooling for the outcoming gas, and on the top we need a lot of energy to burn it, to make it hot and burn it. So there are different systems on the market, and when you want to save natural gas, this is a big point you can do. And look at here, the smaller chamber furnace needs 5 kilowatts per hour on a riding temperature, the pit furnace 13, and this on the picture needs 30 kilowatts per hour. The second thing is you need a thick insulation on the cover, so to save energy. And what we here see, the waves around the cover, you see the gas circulation is not really good. So we have the waves, the heat comes up to the cover, and you lose energy. You give the heating energy in your cooling water and lose it. So I'm really happy with this picture. It's not from me, but it shows many things not really good in the design. Here, this is a cake from an institute in Germany. They do the same, and look how much energy you need for a furnace. And this piece of cake is the hold, and so we see this is the gas burning. Here 20% of the whole process is to burn out the gases. It's really much. This is directly gas heated nitriding furnace. So, and this is a furnace, a different type like this. These are from us. This I am. So you see the boys are big. Here's the size, and so we have the same company, the same process. Everything is the same. The inside volume of the furnace is the same, and there we see about the process. Time is 97 hours. It's a long time not riding, and here we see the energy we needed. And as energy we have natural gas. This customer have a island system to cool down the water, so each plant have his own cooling So we see the energy for this, what we need. And this is the reason we have also a very high electrical energy we need. And here we see it in fact. So we take the whole hours of the process, and so you see what is possible on a new or on a good energy saving design or a normal design. So each furnace are brand new, and so you see gas and electrical and water we save nearly 42% in the process. So the reason is we need so much energy, electrical energy, to cool down the water. Yeah. And in the gas we have the same, so nearly 32% you can save the natural gas in a process. So, and this is only the saving on hold, and this is not so bad. Yeah. What we still have in a program, so we talk about nitriding systems, and but when you have a carburizing system, so you have to quench your parts, and when you use salt for the quenching of your parts, you can take or become the quenching salt back. So when you clean your parts with the water, you have water and the quenching salt, and what we have is a SRU, the salt recovery unit, can clean your washing water, so we get back the salt. Yeah, the dirt is laid down in the system, and the water comes back for washing. Yeah, this is also something to get money back. This is the reason, so you need electrical energy for it and cooling water, but the effect is you get your salt back and can reuse it. So okay, what we see and learn, the greatest potential to save energy is before you order your furnace. So make sure what type of furnace you need for your process. There's the biggest potential to save. The geometry, it have to be a chamber furnace maybe, so you won't put the parts inside with a forklift or something else, or you have a big building, high building, and can use a crane. So a pit furnace is an old technology, but it's a very good technology to save energy. The size effect, make sure the furnace is always full loaded, then a bigger furnace makes sense. If you have a really big furnace and it's not fully loaded, the effect is down. Yeah. The components on the furnace are also not uninterested, so you can do something when you have an old furnace and want to save energy. So see the surface isolation, it's not nice, but the biggest effect is on the flame burner for the furnaces. Yeah, so you see, you can do something. Yeah, so let me say, thank you. So I hope you have some questions. I can do something for you, can help you. No questions?
Well, thank you everybody for attending.